Imagine, you're flying through space, around you, silence, absolute silence, and suddenly, something appears ahead, not a planet, not a star. Darkness. It doesn't reflect light, it doesn't emit it. It simply absorbs everything, even time. This is a black hole, and what we know about it is even more terrifying than fiction. A black hole is a region in space where gravity is so strong that nothing can escape, not even light. That means only one thing. If you fall into it, there's no return. At the center of a black hole lies what is called a singularity, a point where density is infinite, gravity is infinite, the laws of physics stop working. Around it is a boundary, the event horizon. It is the point of no return. The moment you cross it, you disappear from the entire universe. And the most frightening part, at first, black holes were only a theory. In 1915, Albert Einstein described gravity as the curvature of space-time. Soon after, scientists realized if mass becomes too great, space itself can collapse inward. But for a long time, everyone thought it was just mathematics, not reality. Until evidence began to appear, stars moved as if something was pulling them. Invisible objects consumed matter. Radiation vanished without a trace. And then it became clear, black holes are real. And in 2019, humanity saw the first image of a black hole. It was a breakthrough that proved this is not science fiction, this is reality. Black holes are born from death. When a massive star dies, it explodes, a supernova. But sometimes, its core cannot withstand the collapse, and it begins to shrink. Stronger, even stronger, until it becomes so dense that a black hole is formed. There are several types: stellar black holes, formed from stars; supermassive black holes, at the centers of galaxies; hypothetical, microscopic ones. For example, at the center of our galaxy, there's a black hole with the mass of millions of suns. Now the most disturbing part. What happens if you fall into one? At first, nothing. But then, spaghettification. Your body begins to stretch, your legs are pulled stronger, your head weaker, and you are literally stretched into a thin thread. But that's not all. Time begins to slow down. For you, everything feels normal, but for the outside world, you freeze, and gradually you disappear. Forever. Black holes are not just cosmic vacuum cleaners. They can destroy stars. If a star gets too close, it will be torn apart. Create jets, powerful beams of energy that travel thousands of light years. Distort reality. Light bends, space twists. Affect entire galaxies. Supermassive black holes control their evolution. Now, things that sound like science fiction, but are discussed in science. One of the most popular theories, after the work of Albert Einstein and Nathan Rosen, the idea appeared that space and time can be connected by a tunnel. This tunnel is called a wormhole. Imagine a sheet of paper. You fold it in half and pierce it. That's a shortcut between 2 points. The theory suggests a black hole is the entrance, and a white hole, hypothetical, is the exit. But there's a problem. Such tunnels are unstable. They collapse instantly. To pass through, you would need exotic matter with negative energy. And we still don't know if it exists, but if it does, faster than light travel could become possible. This already sounds like a movie plot, but some physicists seriously discuss it. The idea is that when matter collapses into a singularity, it doesn't disappear. It can create a new space-time, meaning every black hole could be a new universe, and our universe could exist inside another black hole. This idea was supported, among others, by Lee Smolin. His hypothesis: Universes reproduce through black holes, and those that create more black holes survive. It's like the evolution of universes. And the most disturbing part, we may never be able to leave and verify it. Near a black hole, something strange happens. Time slows down. This is not a theory. It's a consequence of relativity. Imagine you are near the event horizon. 1 hour passes for you, but on Earth, years or even centuries could pass. So a black hole is like a time machine into the future. But there's a catch. You won't be able to return, which makes it a one-way journey. One of the biggest problems in modern physics, according to quantum mechanics, information cannot disappear. But a black hole seems to destroy it. If you throw into it a book, a computer, even a human, all information about them disappears. This is a contradiction. Stephen Hawking proposed that black holes emit energy, Hawking radiation. And perhaps the information is stored on the event horizon. This is called the holographic principle, meaning the entire volume is like a projection on a surface. In fact, reality could be 2D, while we perceive it as 3D. Again, Stephen Hawking's idea. Black holes are not eternal. They slowly lose mass, and eventually they explode. But small black holes disappear quickly, while large ones live longer than the universe itself. It sounds strange, but black holes can shine. Around them forms an accretion disk, matter that spins and heats up. The temperature there reaches millions of degrees. These are some of the brightest objects in the universe. They also create quasars, extremely powerful energy sources. They can be seen from billions of light years away. We've only just begun to understand black holes. But what if the most important things are still undiscovered? What if there is something more? Something that looks back? And the real question is not what a black hole is, but what lies on the other side.